plot and measure their diameter. And then you'll see when we get into the exercise. So red maple, 6.3. When we get into the exercise for analyzing this data, then you can see the types of uses we put this to. Calculating density, number of trees per acre or per hectare, depending on the system you're using. Something called basal area, which is the cross-sectional area of all the woody stems. So if we cut this tree off at breast height at 4.5 feet and measured the area of that cut stump, that would be the basal area of this tree. So basal area is a key metric in forest ecology, and we'll talk about how we use that in a little bit later to describe the stand. And then we'd measure something else. If we were doing a bunch of plots, another measurement we would take is something called frequency. How many, if we had 10 plots, how many of them does American beech occur in? So frequency might be, in my woods, might be 8 or 9 out of 10 plots are going to have American beech. Some other species that you can see looking around the stand are some red spruce. Those occur a little bit more limited area. So spruce might only occur in 2 or 3 plots out of 10, depending on where I was in the stand. This is a red spruce, so it's a native tree in New England and down through the Appalachians. Some eastern hemlock as well, that might occur in a number of plots. So the 3 measurements that we take, density, basal area, and then frequency, can be combined to give us some real insight into the character of the forest stand that we're working in. Sorry, so that's how we measure the big trees, just recording the diameter of each one for each species. The small trees, right, if we were to count, if we wanted to get an estimate of all of the saplings, seedlings and saplings in an area, counting them in a 1/20th of an acre would take forever, particularly in an area where there was a lot of seedlings and saplings. So if you look just in front of me here, there's a whole thicket of American beech saplings. It would take a long time for us to count all of those in this 1/20th of an acre. So for things that occur at much higher densities and rates of occurrence, we use a smaller plot. And so in this case, we're using a 1/1000th of an acre plot to count all of the species that are greater than a foot tall and less than an inch in diameter. And so this is simply a count. We'll have species in one row and the count of that species in that plot in another row. And so species will be beech and spruce. 1/1000th of an acre has a radius only of 3.7 feet. And so we would do the same thing. If we use this as our plot center, we'd mark out or just have a stick that is 3.7 feet. And then we count all of the seedlings that are greater than a foot tall, but less than an inch in diameter. So this beech is 1. This beech is 2. All right, so I do a count using dots, 1, 2. Then we could just go around in a circle and figure out who's in and who's out and tally them. All right, and so 1/1000th of an acre isn't a very big circle. Even this little tree is out. Those spruces, even though they would be in, they're not a foot tall, so we wouldn't count them. And so we get just a relatively small number of seedlings in the 1/1000th of an acre. This spruce just makes it at a foot, so I will count it. Now, if we're estimating the number of trees now per acre, each one of the large trees, those trees that are over an inch in diameter that we're counting in the 1/20th of an acre plot, we'll get a total number of those trees. It may be 20 or 25 trees that we count in that plot. We multiply that number by 20 to get our density per acre. So if we counted 20 trees in this plot, multiply that by 20 because it's a 1/20th of an acre plot, that would give us 400 trees per acre. For these seedlings, we multiply every one that we count by 1,000 to give us the density of seedlings per acre. So this one spruce that we counted represents 1,000 spruce seedlings per acre. These 2 beech that we counted represent 2,000 beech stems per acre. And if we look around, there are some spruces, some other spruces on the forest floor. There's some hemlocks that we didn't count and that would have been under a foot anyway. And a whole bunch more beech, right? And there's even a white pine seedling in here that wouldn't have counted because it's only a half a foot tall. But hopefully you get the idea. This concept of fixed area plots and then extrapolating to the larger area is a really common ecological inventory technique. We use it not just for counting trees and plants, but we do it to assess densities of wildlife species, geological features, all kinds of other things on the landscape. And this is just one configuration of how to do it. Using circular plots is pretty straightforward, measuring out this fixed radius and then counting everything within them. As we do more of these plots, we would likely encounter more and more species. Some of the things are a little bit less common. If we did more plots, we would eventually encounter them at least once, hopefully. And so sample size, the number of plots you do, is related to the precision and accuracy of your estimates. And we'll talk a little bit more about that as we think about how we analyze this type of data. So hopefully this has all been in focus and you're able to see the things I was pointing at. I will check this video out before I post it, and hope you're all enjoying the way this class is running. Thanks.